Good afternoon and good evening on the East Coast. My name is Ian Howells. I'm the CMO of StorSimple. It's great to be here today. One of the reasons is we won the winner of the Cloud Upstart 2010. And if those of you that were watching on Monday, I think there were about 11,000 people on the live stream. That's when I did the 5-minute version of this presentation. So we're going to go into a lot more depth today and really talk about the cloud as a tier architecture. And one of the things I mentioned on Monday was many of our customers are doubling the amount of content they've got every 6 to 12 months. One of the examples I gave on Monday was a construction company, and they made just a really great example of why this is happening. They were saying if they built a hotel and they inspected it, 10 years ago they'd inspect it, and if they saw a crack in the wall, they'd type in crack in the wall and it was maybe 1K. Now they video it before, they fix it, and they video it afterwards. So when you're actually doubling that amount of content every 6 to 12 months, it forces you to think about a lot of things, maybe from a cost perspective, but also from a time perspective. So how can you manage these volumes of data and still keep it live is a big question. How can you recover when your backup window is more than a weekend is another thing that comes up. So what I'd like to talk about today is how you can use the cloud as a tier or a volume that spans solid state disks, SAS drives, and then everything else goes into the cloud, which is what we call a cloud as a tier architecture. And the name of this presentation really is Building an Enterprise Architecture for Secure High Performance Hybrid Cloud Storage. So the reason it's hybrid is you're actually storing things on-premise and in the cloud. So much of what's in this presentation is an ebook that was published this week. It's available under iBooks on the App Store. Also, if you go to a bit.ly link, which is cloud as a tier with the hyphens, you can get access to a PDF version as well. Then you can, it's also freely available. So you can also go to Netbook Resources, and then you can go to Stories/Cloud as a tier, and there's a number of very good books in that environment. So we're going to take questions at the end, and as part of it, if you put your questions in as we go along, we'll answer them. But the Q&A section is located on the right side of the screen. To enter a question, you select all panelists from the drop-down menu. You type in your question, select send, and then we'll answer those questions at the end of the session. So what I'd like to really talk about in this presentation is it's a bit about StorSimple, just one slide on the background of the company, what we see as the market trends and really the use cases from a customer perspective of how people are using the cloud. Then really walk through specifics and in quite a lot of depth around what is the cloud as a tier architecture, how do you use it for primary storage and get high performance, how do you use it for data protection, for backup and restore, how do you use it for disaster recovery, and how can you use multiple clouds at the same time, which is kind of topical today. And then look at specifically when you're using the cloud, how you optimize it for different types of applications. So how you use it for shared file drives, how you use it for a SharePoint, how do you use it for a SharePoint database, because you really have to have different approaches to get high primary level performance out of each of those. So if you look at a bit of a background on StorSimple, we won Product of the Year. We had a silver in the Storage magazine for the storage systems, and other people in that kind of category, people like Dell, EMC, IBM, Hitachi, and Sun Oracle. But what's kind of important, I think, specifically for the use cases we're talking about, is we've also been certified for Windows Server 2008. So basically, we're a nice fuzzy volume that links into a Windows server, and Microsoft has certified it for primary storage. The other equally important thing is we're certified by VMware to be primary storage for VMware virtualized applications. We were the Gartner Core Vendor of the Year last year. We were the only cloud storage, hybrid cloud storage vendor in the Dow Jones Top 50. As I mentioned before, we were the most promising cloud provider last year at UpCloud 2010. That's enough about StorSimple. One of the things I think when you think about the concept of the cloud that's very important, we like to jokingly say, when it comes to the cloud, content communism doesn't work. What we mean by that is you've got to think like Google or think like Bing, in that really the volumes of content are, as I said before, sometimes doubling every 6 to 12 months. But when you examine that, you've got to get behind the scenes to look at how and where can I use the cloud. So SharePoint is a great example to kind of go through the drivers and how you utilize the architecture best. So with SharePoint, which is a content management system, you may create a 5 megabyte PowerPoint presentation. Then you check it out, And if all you're doing is changing the customer's name on the front page, and you go save and you create a second version, then typically and very often you're going to store another 5 megabytes. And then you may go through that many, many times until you get to version 20. Now, the critical thing here is most people care a lot more about version 20 than they do about the previous 19 versions. So you need to treat that fundamentally differently. And that's what we call the working set. So really, the working set you need to have on really, really fast disks, in this case version 20, but the other versions can gradually migrate to slower disks or out into the cloud. So that's this concept of having a hybrid approach where you have local storage, but it's really one volume that goes through that local storage into the cloud. And the cool things here are you need to think like Google. So if you think about if Google treated every web page the same, when you did a search, the result the result page you wanted could be on page 1 or page 20, which would be useless. So it has a concept of PageRank, which drives the pages that match your search best to page 1, so you get what you want. And you can do a similar kind of concept for content, for the blocks of content, and an algorithm around block rank that drives the blocks that you want onto really fast solid-state disk, the blocks that are slightly less warm or slightly less important to regular drives, then everything else can trickle out to the cloud. And the way you approach that is to really look at that example that I had is if I go from version 1 of my PowerPoint, if all I'm doing is really changing the customer's name, I shouldn't store another 5 megabytes. I should do a concept of deduplication and only store the changed blocks. And deduplication has two really great things about it. It allows you to dramatically reduce the amount of storage because you're not storing that 5 megabyte PowerPoint presentation over and over again. You're just really storing the changed blocks. And you can get up to a 5-fold reduction in the amount of storage. But as importantly, it allows you to look at the world as a series of blocks. And then with each block, you apply a rank to it, and you do transparent tiering. And that's what we call the concept of working set applications. I think what's important about when you do cloud storage and hybrid cloud storage is it's very, very good for certain apps, and you probably wouldn't use it for other applications. The working set apps are particularly good for this kind of environment. So if you think about SharePoint, most people care about the latest version, not the previous versions, and most people use Office, so it deduplicates well, and that's a natural working set. If you think about email, most people want to use today's inbox much more than what they stored a year ago in a PST file. If you think about content management, it's very similar to SharePoint, in that most people want to manage the latest version and read and share the latest version rather than the history of previous versions. If you look at libraries and archives, if you're a construction company, you have a project to build a hotel or a project to build a bridge. And you really want to work on your active projects, but you still need access to previous projects. And the example there is, if you had a failure in something that you built, and there was a famous one in Europe where the French airport had a major problem, you want to be able to get to information about the subcontractors that you were using, the concrete that you were using, the laying processes for the concrete that you're using very quickly. And having a tape process is just not satisfactory in that kind of environment. Another example is virtual machines, where people build big libraries of virtual machines. They maybe create a single virtual machine, then they may change it slightly and store a new virtual machine. Most people want to use the latest virtual machine but have access to previous ones, potentially because that's the configuration one of their customers has got. But the one we see actually being utilized most in the cloud is around shared file drives, whereby people have many terabytes of information stored in shared file drives. And very often the classic way people use that is they copy a presentation, they'll paste it, they'll edit it to customize it for what they're going to be using it for, and then they'll not really use it ever again. So again, it's very similar to SharePoint that you get the same slides in that example used over and over again. So they deduplicate well, and there's an actual working set of the new things that you're working on, and the old things are very rarely accessed, but most people don't want to delete them. So we see that as the natural first application for using hybrid cloud storage. So when we think about using the cloud for storage, it makes perfect sense when we look at it from that content communism perspective and block rank. There's some core things you need to be able to take into account, that there's a different interface. It has a HTTP REST API, which is fundamentally different to the API that your applications are using. So you don't want to have to rewrite your applications. Also, one of the kind of the things we say jokingly is you can't treat the cloud as a big dumb disk at the end of a WAN. Because it will be a very disappointing experience. So you have to manage the latency between your on-premise disks and and then the cloud, and take into account the bandwidth, and then minimize the amount of traffic that goes over that wide area network. Then there's also security, which comes up pretty regularly. So how are you going to manage things like HIPAA and compliance risk in this kind of environment? And those are the things that we set out to fix out of the box. So when you look at the approach we took around hybrid cloud storage, was to have this concept of a volume or enterprise cloud drive for Windows and VMware applications. So the first thing that's really important is the appliance is installed in your data center. It's installed on your local area network, and it looks to your Windows server just like an iSCSI volume. So what that really means is it's just another disk that happens to tier into the cloud. But that means all of your applications work out of the box with no change against this iSCSI volume. And that's what's been certified by both Microsoft and VMware for primary storage. So that's a really big deal in that you can suddenly, without any change, use all of your on-premises applications and tier them into the cloud out of the box. The focus then is really the whole focus, how do I reduce the cost of my storage if it's really growing at the rate we were discussing before? So one of the first things we're able to do is to what's called thinly provision into the cloud. So if you think about, one of the analogies is, if you run out of space on your laptop, you've got to go down the store and buy a new disk and install it. And that can kind of happen at a macro level in an organization. So what people want to be able to do is to provision enough disks so that they're not going to run out of it, and that's called thinly provisioning. So we could instantly provision 50 terabytes into the cloud, and if we're only currently using half a terabyte, that's all we really pay for. So you can have simple thin provisioning, but within that volume that you've provisioned, you get deduplication. So if we go back to that example before, when I talked about the PowerPoint version going from version 1 to version 2 to version 20, if you could, one approach is they're all 5 megabytes, that's 100 megabytes. In our case, it's probably going to reduced by a factor of probably 5, so it's going to be nearer 20 megabytes because you have a natural deduplication in that kind of usage. So what you're then getting is, if you really want to take this approach, you want to get the speed that you traditionally get if the content or the data was on-premise. So what we're really doing here is keeping the blocks, due to the block rank algorithm, on not just regular disk, but very, very fast solid-state disk. So the frequently used data is going to be accessed typically quicker than you traditionally would have had before. But the colder data automatically goes out into the cloud. And you can back up to the cloud as well. And what's important is you can actually write to more than one cloud at the same time. The other critical thing is around security. And we'll go into this a little bit more depth, but when you have this whole concept of a volume that spans solid-state disk, regular spinning disk, and the cloud, everything that goes out to the cloud of the wide area network needs to be encrypted. And then you manage the keys physically on-premise, because you don't want to have highly encrypted data and then give somebody the key to decrypt it. Then one of the critical things, and that our co-founders, one half of the team is from the Cisco WAN optimization groups. We have a lot of experience around how do you do WAN optimization and minimize the amount of traffic that goes over the wide area network. So you need to do really WAN acceleration, to do compression, and TCP/IP optimization as well. To really focus upon minimizing the number of blocks that really go over this wide area network. The other key thing is, if you're going to run applications in this environment, you want to get true enterprise class high availability. So you need to build into the system no single point of failure. You need to be able to do non-disruptive software upgrades, because that's what people are used to today, and they don't want to go backwards when they're storing content in the cloud. And the other thing is different applications behave in different ways. So you need to have an infrastructure and a plug-in architecture for maybe treating a Windows SharePoint database differently to SharePoint content, to treating a PST file differently to today's email, and effectively managing maybe VMware libraries or shared file drives. So we have that kind of architecture as well. And then a way to do backup to the cloud that's still very highly performant. So if you treat the cloud, as I said, as a big dumb disk at the end of a WAN, it's going to be disappointing, because if you have a 100 terabyte backup, it's going to take you a really, really long time to recover it if it's a single tarball. So you need to be smarter about the way you move data and you recover in the case of a cloud and hybrid cloud storage. So that's the concept, what really hybrid cloud storage does. It's an appliance that you install inside your data center on a network, and it transparently takes your existing applications and allows you to have a volume that spans into the cloud, so you can run your existing content on the appliance and you can tier it into the cloud and do backup and recovery to the cloud. So when you look at really one of the big impacts we see of this is typically how people do storage today. And we think this is the way that organizations are thinking about using the cloud, is traditionally you're going to have primary storage and disk-based backup storage. You're going to have to archive and have archival storage. You're eventually going to write to a tape. You're going to replicate to a different, to mirror to a different site, and you're going to manage those tapes off-site. And that tends to be how people do things today. And they do that not just in their data center, but in typically remote offices as well. They'll recreate this whole infrastructure, or have a massive pipe going to that remote office, and then they'll do remote management for remote backup and remote recovery. One of the inherent advantages of the cloud is it's available from all your offices. And by using hybrid cloud storage as an appliance with a cloud, you can have a single box to do all of that. So it dramatically simplifies the whole approach to managing storage. And as well as being significantly more cost effective, we're seeing it being about 80 to 90% more cost effective. It's just much simpler to manage a single box in each regional office. You typically don't need dedicated personnel to it, and you can just integrate companies that you're buying into this environment much more quickly. And if you look at how most people have regional offices, they have a common set of virtualized applications that they want to roll out, and you can have some compute for that in every office, and then you just have for those applications a single system to manage the storage and then the off-site backup. So this is what we see as a major use case either for typical regional offices for the Global 5000 or for mid-sized companies with similar kind of environments. So one example of this is Rockford Construction, which was using SharePoint in this case, and they were using Windows Azure, and they were storing all their construction project data, things like office files, computer-aided design drawings, the videos I mentioned before. They were doing projects over 43 states, and they were sharing the content across their internal design team and the field, and they have to store this project data for 10 years. Their big driver was the cost of the whole storage infrastructure across primary data protection, which is backup and recovery, archival and disaster recovery. And they were at the point on their existing storage system, they were running out of disk space. So they were having to evaluate whether to buy a new SAN or not. Their big challenges were, how do I scale? How do I get security in the cloud? And they were using StorSimple with a database optimizer for SharePoint. And one of the big drivers there was it was a 10-minute installation. They had the elasticity of the cloud to manage the growth they were experiencing and the projected growth. They were able to scale the content very easily and still keep the performance that the users wanted. They were able to have this concept of an online archive. So the volume was going through the solid-state disk into the spinning drives into the cloud. And they didn't have to then take the data offline and archive it. They could just keep it live because it was cost-effective enough to store it in the cloud. They had high levels of encryption in the cloud. It was about 90% less cost. They were using the cloud for off-site backups, which are obviously safer than on-site backups, and they got disaster recovery. And this was nominated for Best Practices Awards for AIM, which is the Association of Information Management, and Storage and Network World as well. So it's just a great example that epitomizes in a mid-sized company very much what you see in the Global 1000 as well in regional companies. And we see a similar kind of thing in the Global 1000 where they're looking at each of these. They may be coming to the end of a lease with their existing storage. They also have to, for Sarbanes-Oxley reasons, store things for 5 or 10 years. They want to have in every regional office an integrated lights-out solution for primary data protection and archival. They want to be able to manage that remotely. And the cloud really makes that possible. It's really the combination of a simple single box and the cloud gives you very, very similar kind of benefits. So when we look at now the cloud as a tier architecture, what we're seeing here is that you really have 3 layers. You have the solid-state disk layer, you have the second tier, which is spinning drives, and then you have the big amount in the cloud. And from a security perspective, what's critical is every single block that goes out to the cloud has very high levels of encryption placed on it. And as we said, what's important is the key is kept on premises. And I think when people always talk about the cloud and around security, and we were discussing this on the panel on Monday, is that we think it's really a matter of education. Everybody talks about security in the cloud, but in 5 years' time, we'll really look back at the cloud as potentially increasing the security levels that we already have. If you look at most breaches of security, it involves human beings accessing unencrypted data. There's kind of a famous thing in the UK whereby the government wanted to get everybody's primary social security number and primary bank details, and they put it on a disk to ship it from the north of England to London, and that was being sold on the internet in hours. And also, if you look at the recent things around people reading people's emails on a hosted environments, it was because of unencrypted data. Whereas if you use high levels of encryption in the cloud, you simply couldn't do those kind of things. And it's very much like people 5 years ago worrying about using their credit card on the internet. So I think the internet, if you use it the cloud, if you use it appropriately, can actually increase the security that you've got. So we think about this as a framework that we're working in from a cloud as a tier architecture. We already have the three tiers: a really fast solid-state disk, the slower spinning disk, and then the wide area network connecting us to the cloud. So what we're able to do now is instantly provision as much content as we want. So, for example, we can have an X drive, which is our shared file drive. We can provision now up to 100 terabytes pretty much instantly, but only pay for what we're using. So we're not going to run out of capacity on our volumes. So you really get this concept of instant thin provisioning across multiple tiers, and you really simply manage the volume, but you get utility-based billing. So that's the kind of what we see as the common use case, and the first thing that most people do is really look at their shared file drives and very often create a big volume that goes into the cloud. And their internal shared file drives are typically 2 terabytes, up to 2 terabytes in size, and they move things across in 2 terabyte chunks. So the next thing we need to be able to really do in a cloud as a tier architecture is think about different kind of applications. So if we think about SharePoint, for example, traditionally SharePoint would store everything in its database, but in 2010 SharePoint had a technique called RBS, remote blob separation, to take the content out of the database and put that in a content volume. And that makes the database 95 to 99% smaller. So if we think about that, we wouldn't want to put our database out in the cloud. We want to get that for very, very rapid access. We want to really pin that to solid-state disk. So you have a concept of a volume, which really is just for solid-state disk. Then if you think about the log file, that's really sequential write. So what you want to be able to do is to use solid-state disk or spinning disks. And spinning disks are actually very good for sequential writes. And then you want to have the concept of a volume that spans solid-state, spinning disks, and the cloud, which we call our blob volume. So this whole concept of being able to plug in application optimization into the architecture controls really how the block rank algorithm is used and the kind of the mediums and tiers that the volumes span. So then the core thing then is how do you do backup across not just one volume but a volume group. So what we're able to do as well is support the Microsoft VSS framework, so you can do a consistent cloud snapshot across not just one volume, but the database, the log file, and the blob volume. So now when we do that, what we're effectively doing is moving the content that we've got, and we can do an off-site snapshot or backup completely in the cloud. So if we lose physically our data center, we have everything we need in the cloud to do a recovery. And the key thing here is you've got to be smart about the way you do that. If this is 100 terabytes of total volume of content and data here, you can't really move that very, very quickly into the cloud. So this is really the approach we see in a cloud as a tier architecture. So the core thing when you think about backing up to the cloud is you can't create 100 terabyte tarball and move that over a network, even if it's in a background process, because if it's one big lump when you want to recover it, it takes a very, very long time to recover. And one of the things we jokingly say, which has a lot of truth in it, is what's the quickest way to back up to the cloud? And the answer is don't do it, because you don't have to. So the content that's already in the cloud, in this case, we can simply very quickly back up in the cloud because it's already there. So we have pointers to the blocks that are already there. And all you really have to move over the wide area network for the first time you do this is that the content and data that's on the appliance. So if we think about this, it's really just the database, the log file, and the content that's on the appliance we move into the cloud. Now we have a base set. And again, we're doing that as a consistent backup. So even if we lost the appliance or the data center, everything is now in the cloud. Now the key thing when you do a second, third, or any subsequent cloud snapshot, what you've already had happening is certain blocks will have changed on the appliance and many won't have changed. So if you want to do a cloud snapshot and move everything into the cloud, all you need to do is to move those blocks that have changed on the solid state and SAS tier into the cloud, and now you can do even if you have 100 terabytes or a very large amount of content or data, all you're moving is the changed blocks, so you can do really, really quick backups to the cloud, and it takes it down from many, many hours to minutes because you're already moving the working set blocks into the cloud. Now the cool thing now is, what about recovery? And I spoke to somebody at a Fortune 50 company. He kind of joked and said, nobody cares about backup, but they really, really care about recovery because they want to have it happening very quickly. And this is the approach you need to focus upon, really the recovery time objective, is how, if you have a snapshot into the cloud, do you recover very, very quickly without bringing everything physically into your data center. And it really takes the comparison down from hours to minutes, and it's much, much quicker than an off-site tape recovery. So what we've really got here is we've got a completely consistent, completely isolated backup that's in the cloud of all the blocks from a previous cloud snapshot, and we've got snaps for previous for points in time. So what I'm able to do now is I can just mount what I've got in the cloud as a series of volumes, and then all I'm really doing is, when I've got the metadata, because I've mounted the volumes, I start accessing the data as soon as I mount it very, very quickly because I've just pulled the metadata on premise, and then I'm pulling together and pulling out the blocks that I want to use. Initially I'm pulling them from the cloud, but then when I'm using them, I'm effectively recreating my working set on solid state disk, which is much, much quicker. And over time, I'm basically repopulating and recreating my working set, and the system will get continuously quicker and quicker until I get a steady state working set again. And this really gives us the best of both worlds. You get very, very quick recovery, and then you're gradually building up your speed because you're only bringing onto the appliance what you need to work. And you can do smart things like a read ahead to get the blocks of data that are related to the blocks that you're pulling to recreate the working set more quickly. So you get the benefit of off-site data protection, but you still get very rapid recovery. And what we looked at there was really the concept of going to a data center and doing a completely isolated cloud snapshot, and then recovering that cloud snapshot back into the data center. And we could do that in the case of a failure, or in the case of changing the appliance. But what you can also do now is you can do that not just within this one data center, you can do that and recover in a different data center very, very easily. So in this case, for example, London will have done a snapshot into the cloud, and everything in the cloud is available. And that can be either a virtual machine, or it can be data, or it can be content. And if I want to recover in San Francisco, all I have to be able to do is to take the configuration file from my London appliance, which is a simple XML configuration file. I load that up, and then I use my internal key management processes to put the key in to decrypt the data. And I can be up and running in San Francisco in minutes. So the cloud as a tier gives you this whole concept of not just recovering in your primary location, but using the cloud as a common place to back up to get very rapid recovery to different locations as well. So what I'd like to look at now is, when we look at those cloud as a tier concepts, how you can do some optimization around them to get even quicker recovery and be able to do better testing of your DR processes. So what I'd like to do before I go into that is just go through some core concepts. And we talk about, people often use the word bucket when you come to the cloud. So look at, the whole concept of, what's in a bucket. So if you think about, if you've really got a volume that spans your really fast solid state disk, your spinning disks in the cloud, you can either have data or content on it, or you can have virtual machines on it. Now, everything that goes into the cloud is deduped, it's compressed, and it's encrypted, and you only send incremental changes over the wide area network. So there are three ways you can do data protection or backup. The first is a snapshot onto the appliance. Now, obviously, that's really, really quick, but if you lose the appliance, then you lose the snapshot. So the second approach is to do what's called a cloud snapshot. And what this does is, as we saw before, it flushes all of the blocks on the appliance into the cloud, and then it has a set of pointers which are the snapshots physically stored in the cloud. So if you lose the appliance, then that doesn't matter because you have a completely isolated snap in the cloud. Now, in this scenario, what you've really got is a single bucket. So you could have a rogue software application that writes over the volumes and the buckets. So potentially some software could overwrite not just your data, but your snapshot as well. So we have a third concept called a cloud clone. This is really like a cloud snapshot, but you place it into a completely separate bucket, potentially in a completely separate data center. So you've really copied that cloud snapshot and put it in a completely isolated place that nothing can really overwrite it. So it's really as safe as tape. So those are the three kind of concepts that we want to talk about now and look at how you can do some more advanced things using cloud as a tier architecture. So one of the things you're able to do, if you talk to people about tape recovery and say, how often do you test your tape disaster recovery procedures, most people go either very red in the face or they go very quiet because it's just so painful, they very rarely do it. And if they do it, well, when they do it, they tend to do it from the place they're doing a backup from. So if we think about here, if we have New York, it can have a cloud volume that spans the appliance and the cloud, and it can have a cloud snapshot. And what we're able to do here is we can mount that cloud snapshot from London or from Tokyo, and we can test our disaster recovery procedures from different locations. So this really removes the need for tape validation, and it makes it simple enough to do that you can do it very regularly, and not only can you do it from your primary center, you can do it from multiple geographies. So you can maybe test, London on Monday, Tokyo on Tuesday, New York on Wednesday, and have much better procedures in place for when you do have a disaster because by their nature, they're very, very unpredictable. And you think about with tape, it's kind of it did a lot of work on Wall Street, and one of the procedures there for getting tape in an emergency to the organization, to the firm, was on a plane. And when 9/11 happened, you couldn't put it on a plane. If you think about when Katrina happened, tapes were very, very safe, but a lot of them were in flooded mines that you couldn't access. So disasters by their nature are very, very unpredictable, and you need to be able to plan for them across multiple geographies. So, for example, with a recent earthquake in Japan, you really want to be able to do some DR testing, not just within that region, but within other regions as well. So the cloud is just a natural way to do this. So if you look at what we've got here, what we can do is now increase the performance of disaster recovery as well. So what we're able to do now is called Snapshot Geo-Replication. So the cloud is, again, common to both data centers. So I can take a cloud snapshot, and then I can mount it in London. So I really pull it and pre-mount it in London. Then if I do an incremental snapshot in New York, only the blocks that have changed are sent to the cloud, and then we replicate those to London. Then I pre-mount it. So what this means is that if the data center goes down in New York, I've pre-mounted the latest New York cloud snapshot in London, and it's instantly available with no mounting. So you can have very, very fast recovery times without a dedicated WAN because you're using the cloud as a common medium to share data across these geographies. The other kind of thing when we spoke about before, we talked about the snapshot, the cloud snapshot, and the cloud clone. Is what's kind of interesting is in reality, people will do them at different frequencies. So you'll have people doing very, very regular snapshots, maybe every hour, every few hours. They'll do less regular cloud snapshots and even less regular cloud clones to have different types of data protection. But what's kind of interesting, if you've done a very regular cloud a snapshot, then you've done a cloud snapshot, the reality is many of the blocks in your cloud snapshot are already on the appliance in the snapshot. So if you want to recover from a cloud snapshot, you don't really need to bring relevant blocks back from there. You can have them on the appliance. So we call it block preference optimization. So if you're recovering from a cloud snapshot and the block that you want is already on the snapshot, you read it from solid state disk or SAS drives, spinning drives, instead of from the cloud. So you really get the protection of the cloud with local performance because we have this block preference optimization. So when you look at these appliances that you put in your data center, they just look like regular 2U appliances. They are just regular SCSI devices, so everything works out of the box. And the software in the box does the block rank, does the tiering, does the dedupe, does the optimized snapshots, has a 10 gig option. You have dual controllers, you have no single point of failure, you can do non-disruptive software upgrades. It's been certified by Microsoft and VMware. You can integrate to private or public clouds. You can integrate to multiple clouds at the same time. It automates the whole concept of tiering and archival. It automates the whole process of cloud snapshots with fast online restores. It does the clones to replace tapes. It really treats the cloud as a secondary data center for DR, and it enables you to use your cloud snapshots potentially for staging and testing. So if we think about if somebody's doing an upgrade from SharePoint 2007 to SharePoint 2010, it's pretty common to test it on a small database, to test if your customizations work, to test if the upgrade works. We make it as easy to do that on the full live database. The other critical thing around this environment is you want to really have high availability built into the system. So when you're going to the cloud, you have multiple redundant paths going into there. You get automatic failover. You get load balancing. You get, as we mentioned before, the non-disruptive upgrades. You can have multiple interfaces. You have multiple power supplies. You have multiple fans. You have RAID protection. You can have hot spare disks. You can pull out disks as you're live. You can store multiple copies in the cloud. You can use primary and secondary buckets. And the other thing which we announced as well in a recent release is you can actually write, if you have 4 ports in the back, each port can go to a cloud provider, and you can have multiple accounts. And that's pretty useful because you may have, if you go into Windows Azure, you may have a HR account and a marketing account. It allows you to do different billing. So how much is marketing using? How much is HR using? But you can also go to multiple cloud providers at the same time, and you can use the server to do RAID across those multiple cloud providers. So again, the whole focus here is to get very, very high levels of availability and integrate the cloud as your primary device that also gives you archival, data protection, and DR. The core thing then is when you look at it as a single device, it allows you to really reuse one infrastructure for primary, data backup, recovery, archival, and DR. And we have a built-in dashboard where you can put in various costings that you've got, and you can, on a regular basis, just look at the ROI that you've got from using the cloud and the cloud provider. But the other kind of important thing which we kind of mentioned briefly was when you're using hybrid cloud storage, you need to be smart and complement the applications that are using those volumes. So you shouldn't treat the example I gave before was a SharePoint database the same as a SharePoint content volume, because you really want to pin the database to solid-state disk. And if any of you put that on your laptop, you know the kind of difference in performance that you get. So the other important thing is you need to consumerize that experience. So it's really a pick list. You can choose whether to have a SharePoint database volume, a SharePoint blob volume, a VMware data store volume, a file server volume, or an Exchange mailbox volume. And each of those has slightly different behavior to make sure that the blocks and the block rank algorithm is modified to be optimized to that kind of application. So the other kind of thing when you think about these volumes and the app from an application perspective and a working set perspective, we mentioned before data recovery. So if I've got a shared file drive or a folder that tiers into the cloud, I may have a disaster and have to recover everything from that volume. You may not always want to do that. So if I've got a live volume and somebody has gone into that shared file drive and they've deleted a PowerPoint, what we're able to do is to keep my live tiered volume that tiers into the cloud. I can go back to yesterday's snapshot and present it and mount it, and it looks just like regular folders. So the end user can go through there, look at yesterday's cloud snapshot, find the folder where they were working, find the individual PowerPoint that they deleted by mistake, copy it, then paste it to the live volume from today. So you can get item level recovery for files and folders very, very easily. But that's not so easy when you've got either SharePoint or Exchange, because it looks kind of different. So what you want to be able to do is do a similar functional thing in your cloud snapshots on lists and on content, or in Exchange on a mailbox or email. So what you're able to do here is to really look at, in the example with SharePoint, and go to a cloud clone or a cloud snap, go to the data protection manager, then you can mount it, but then what you're able to do is have an interface that makes it look like SharePoint in this case. to do the data restore, and you can pick the list or the individual piece of content and restore it into your SharePoint database. We do a similar kind of thing for Exchange as well. The core thing here is consumerizing the whole experience of tiering into the cloud, doing data protection or backup into the cloud, and then recovering it. So it makes it very, very easy for people to use. So in a summary, what we're really seeing here is we see the cloud has some fundamental advantages. You can connect to it. You can instantly provision into the cloud. You get elastic expansion in the cloud. You get out-of-the-box high availability through replication. You get instant disaster recovery. And it changes the way you can think about having storage, particularly in regional offices or mid-sized companies. And we see this as the major trend, in that people are looking from having individual components for each piece of storage to having a single hybrid storage approach. And by using things like solid-state disk and tiering, you can get primary levels of performance. You can get snapshots on your appliance or in the cloud that are off-site. You can get live archives, so you don't really have to archive off old data, because you only really do that for cost reasons. You don't do it because you want to, and you make it cost-effective enough to have live archives. You can have disaster recovery through cloud clones. You can have snapshotting and mirroring for replication, and you can do geo-validation of your cloud snapshots or your cloud clones from multiple geographies. And it dramatically lowers the cost that you've got in these kind of environments, and it makes it significantly simpler to manage them. And we've also seen, in a mergers and acquisitions perspective, is when you're buying up other companies, you want to be able to integrate them into your existing IT infrastructure. And it makes it much easier and quicker to integrate a new office into your corporate IT infrastructure. So that's really our approach when we're looking at cloud as a tier. And the book is an ebook that's freely available if you go to the bit.ly address and then cloud as a tier. If you want to get the PDF version, there's a number of cloud books on www.cloudbook.net/resources/stories. There's numerous books there. There's some videos on StorSimple.com. You can follow me at Dr. Ian Howells on Twitter. And all I like to do is look at some questions and answers now. And if you look at the first question is the life cycle of the product. Shouldn't the client buy new one every couple of years? I think what we've got here is we have redundancy built into it, and people will typically buy multiple hybrid cloud storage controllers. So what we're really doing here is having an appliance that spans both solid-state disk, SAS drives, and the cloud. And you've got a lot more data protection built into it because you're already storing your cloud snaps in the cloud with built-in redundancy. So I think what you're looking at is very often people redo their storage because they've run out of capacity. And what we're able to do here is to have much more elastic capacity that you can grow much more quickly. So we think it allows you to plan more easily, so you don't need to just buy new one every couple of years. What we have seen is when you look at a working set, different applications may behave differently. So we've seen people have two hybrid cloud storage controllers, one for your Office documents and one for your VMs. So we've seen that rather than buying two for renewing the Office document ones. Another question from John is, which cloud storage providers do you work with? We work with multiple private and public cloud storage providers. We work with Windows Azure, with Amazon, with AT&T, with Zeta, and with EMC Atmos. EMC Atmos is obviously the private cloud. We've designed it so it's pretty open, so we will be adding in other cloud providers. That's going to be driven by customer demand. Yeah, so that's the one we've seen most subsequent demand for is OpenStack. So that's another question from John. So yes, that's one of the things we'll be planning on working with. So are there any other questions? Okay, well, thank you everybody for listening in. As I said, there's more information on the cloud as a tier from both StorSimple and multiple other vendors and authors. There's some videos which show you how to install the appliance in about a 7-minute install on StorSimple.com, and there's also some videos of how you do cloud clones as well by our CTO. Thanks for listening, and enjoy the rest of the conference.